Today we discuss about the functions. Functions is a major part of C programming. So based on that function, the classes are derived based on that function. Function is one of the entity of classes. So based on that classes, the object oriented programming concept is built. So now we discuss about the functions. So the functions are unit. So the functions are unit which perform a particular task. That is, each and every unit perform particular task. These units are linked together by the help of function call. So that process name is function call. So a C program consists of more function. The functions are units. That units are linked together by the help of function call. So it's just like our human lifestyle. In our human lifestyle, each and every person has a specific task. For example, the doctor has a specific task. He know about to give the treatment. So the plumber has a specific task. He know about the plumbing work. So the electrician has some task. Then engineers. So Toby. So each and every person has a specific task. That person so do that work properly. So if the doctor is need the service of bike mechanic or that is for car mechanic, he simply call that function, that is call that mechanic. Mechanic is one of the function. So him simply call that function, the doctor repair the car. So if that mechanic required medical treatment, he simply call the doctor, then he utilize the service of doctor. So each and every person do specific work. If that person want another person work, simply call that person, then utilize the service. So this is our normal human lifestyle. So just like that human lifestyle, C program also consists of more function. Each function perform a specific task. Suppose if we want that task, that is if we want that service, we simply call the function. So that function are categorized into two types. One is function without arguments, function with arguments. If we give some value to the function, if we pass the value to the function, that value is called arguments. If we want to service our car, just we simply call the mechanic, we give some money and instructions. Then he make repairing work on our car, then he will return the car. So we want to give some, then we get some. So each and every function may required or may not required arguments. Suppose if we pass the argument, this is with the argument. If we not pass the argument, this is function without argument. In some cases, we no need to give any amount or service to a specific function. That function do some work and give, that is we get only services from others. We no need to give anything. So this kind of function is called function without argument. For example, we doesn't give any value to the parents, but parents does not get anything from us. Nowadays we does not give anything to the parents. So just parents are give some value, some money and some related things. So parents are give to us. This is, suppose the parents is give to us, this is with argument. But we does if we call the parents, we does not give anything. So this is without arguments. So some functions require some value, based on that it process, then it will return the result. Some function does not need any value, but it process, it gives some service. So if the function requires some value, this is argument, the function with argument. The function does not need any input, that is any value, that is function without arguments. The with argument, function with argument also furtherly divided into two types. One is call by value, call by reference. That is function call with value, then with reference. So value means just we pass the value. Reference means we pass the address. We learn about the address, then we will pass the reference. So function majorly categorized into function without argument, function with arguments. So function with argument furtherly classified into call by value and call by reference. Through this program, we learn about the function without arguments. So this program consists of totally 4 functions. One is main function. This is a special function to the program because compiler start with main, that is opening brace, that end with closing brace of main function. So this is a special function. Then next one is a function name is Salem. Next one is Mumbai. Next one function is Chennai. So what is the function? The structure of function is, the first we give function name. So what is the syntax of function name? First we give the name, then followed by a pair of parentheses. That name should be user defined one. That name should not be a keywords of C. So first we give name. That name is the construction rule is equivalent to the variable construction name, construction rule, that is up to 8 characters, only alphabets, numbers and underscore. The first letter should be alphabets. These rules are applicable to construct the function name. So the name, the followed by a pair of parentheses. This is a function name. This is a head of the function. Then we put opening brace, closing brace. So the next of main function, we put one opening brace, then we give some valid C statements, then we put the closing brace. Within the opening brace, closing brace, this is the body of the function. So in this example, main is a function name, then opening brace, closing brace. So totally 3 statement is there. So this is the body of the function. So entirely, that is that main, Salem, Chennai, Mumbai, this is the total, that is a function. This is a function. This is a function name. This is the elements of function. This is entirely called as function. So this is a Salem. This is one of the function. So opening brace, closing brace, this is the body of the function. This is the head of the function. So this is Salem function. This is Mumbai function. This is Chennai function. The compiler start with main. Then first it call the Salem function. How we call the function? Just we put Salem, parenthesis, then we put a semicolon. So if without the semicolon, it is a head of the function. With semicolon, it is a function call. Here we call the Salem function. The control is transferred to Salem. Then it execute the statement. So it displays just Tamil Nadu. We execute the program. First it call the Salem function. So the control is transferred to Salem function. It execute the statement. So it display Tamil Nadu. Then the control, the opening closing brace of Salem function, at the time of reaching of Salem function closing brace, the control is transferred to main function. Then the next statement, Chennai function. Next statement is Chennai, the function calling of Chennai function. So it's called the Chennai function. So it's the control is transferred to here. So then it's executed. Here printf, it's not a Chennai, here printf, it is a typing error. So it's a printf, Rajasthan. So secondly it display Rajasthan. Then it's called Mumbai. It display Maharashtra. So the first call Salem, then second call Chennai, the second call Mumbai. The third one is Mumbai. So it's executed. First the control transfer to Salem function and display Tamil Nadu. The second is transfer to Chennai, display Rajasthan. Then third one is control transfer to Maharashtra, it display that is Mumbai function, it display Maharashtra. And the output order is it is typing error. First Tamil Nadu, then Rajasthan, the last one is Maharashtra. First Tamil Nadu, then Rajasthan, the last one is Maharashtra. So the we no need to call the function in sequentially, because the main function is a first function, the second is Salem, third Mumbai, fourth one is Chennai. In order, the Salem is a first, the second place is Mumbai, the third one is Chennai. But here we call Salem, it is a first function. So then we call Chennai, it is a last function, that is third function. It's not required sequence. We not required to follow the sequence. So we can call any function at any time, any number of times. So this is an example for function without arguments. So in Salem function, this is a empty parenthesis. Within a parenthesis, no variables. So this is without argument. If within a parenthesis has any variable, this is with argument. But here no arguments. So the function without arguments. These functions are without arguments. No argument is there. Through this example, we learn about the function with arguments, that is call by value, because function with arguments furtherly classified into two types. One is call by value and another one is call by reference. Now we discuss about the call by value, that is function with argument, call by value. This example has two functions. This program consists of two functions. This is one of the program, this is next program. First we discuss this program. This consists of two functions, that is one function is main function, another function is average function. So in main function we declare three variables, integer variable, then next statement we declare float variable, then we give some information to the user through printf function, that is enter three values. Then we get three values for A, B and C. So then after receiving the value and assign to the ABC through scanf statement, then we call the function. This is a function name. This is a function. We call the average function. Within a parenthesis, we give three variables. This is the arguments. The function name, after the name of the name, the parenthesis there. Within a parenthesis, there are some variables. So this is arguments. This function call is with argument. The function call with arguments. This is the value A, B, C. For example, if it asks enter three values, just we enter 20, 35, 40. The 20, 35, 40 is assigned to A, B, C respectively. The A value is 20, B is 35, A, C is 40. Then through this statement, we call the average function. We pass three values, that is A is transferred to X, B value is transferred to Y, C value is transferred to Z, because A, B, C are integer variable. So here we declare integer variable. So integer this variable at the time of function calling we pass arguments. This argument is called actual arguments. At the time of function call we pass some arguments. This kind of argument is called as actual arguments. At the function definition, this is a function definition. This one is function call. This one is function call. This is a function definition. At the time of function, in the function call, we put some variable within a parenthesis. This argument is called actual argument. At the time of function definition, if we put some variable within this parenthesis, this argument is called as formal arguments. The calling time, that arguments called as actual argument. The receiving time, that argument called as formal arguments. Now ABC value are transferred to X, Y, Z respectively. That A value 20 is transferred to X, B value 35 is transferred to Y, C value 40 is transferred to Z, as per according to our example. So integer xyz, float z. Then here we add three values. This is also printing mistake, typing error. So x plus y plus z. This one is x plus y plus z. So x plus y plus z, because abc is a local variable to main function, here we cannot be able to access that variable. So this is a typing error, x y z, x plus y plus z. Here x plus y plus z slash 3.0. So what is the value of x plus y plus z? X is 20, a b c is a typing error. So here we put x plus y plus z. So x value is 20, y value is 35, z value is 40. So 20 plus 35 plus 40. As per the priority rule, the first it execute within the parenthesis. So 20 plus 35, 55 plus 40, 95. So then the division is executed. So this is a plus b plus, that is x plus y plus z is here integer variables. So the result will be integer. So that is 95. But divided by 3.0. 3.0 is a float. Integer float, the result will be float. Integer float yield float. So 95 divided by 3. 95 divided by 3. 95 divided by 3. That is 31 point something. 31 point something. But z is a float variable. Z is a float variable. So integer float yield float. So 31.33. 95. 31 point something, 31.66, sorry, 31.66. So 95 divided by 3.0, 95 is integer, 3.0 is a float. So 35 divided by 95 divided by 3.0, the result will be 31.66. Z is also a float variable, so it has 4 bytes. So it can store a float value. But here integer float yield float. So that 31.66 stored into z. Then the result is return of z. So now the value is written here, because here we call the function. So the control transfer to this function. Then return is also come to the calling area. So the value 31.66. So the average is also a float. So that value is assigned to our avg. Then we get the value from through printf, average equal to avg. So what will be the result? 31.66. No, it display only average equal to 31.0, not 31.66. So what is the problem in this? So up to this z has 31.66. At the time of return, here avg is a float variable. So at the time of return, it changed as 31. Why it changed? So just we see this program, then we can easily understand that the problem. That is here integer abc. So here we declare the function. We declare function float average. Here no declaration is there. So the default declaration of function is integer. If we not declare, it assume as integer function. So what is the integer function, float function? The integer function, it return integer value. The float type function, so it return float value. But in this program, we didn't declare the function. So the default type of function is integer. So at the time of return, z value is 31.66. At the time of return, this is an integer function. By defaultly, it is a integer function. At the time of return, at the time of return, it come only 31, not 31.66, because it is an integer function. Because a default type of function is integer, so it returns 31 only. Then we assign 31 to avg. Avg is a float, so it changes 31.0. The result will be 31.0. Here we declare that function. If we want to return other than integer, we must declare like that, float average. So this is a function declaration. This one is a function calling. This is actual argument. This is function calling. And the function definition also we put float. Here we no type specification. Here we specify the type float. So this is a float function. This is defaultly integer function because we know put any type. Here we specify the type. So it is a float function. So it returned 31.66 as 31.66. Here it is an integer function, written 31.66 as 31 only. Here 31.66 written 31.66. So because it is written float, that 31.6 is assigned to AVG. So the result is average equal to 31.66. So this is a function declaration. This is a function calling. This is function prototype. This is called the type specification before the function is function prototype. We want to specify the prototype of function. So we want to return other than integer value, we must declare in the calling function. Declare in the calling function and also declare in the function name of function name in function definition. So this is a function definition because function definition consists of function head, function body. So before to learn function with argument, the next we want to learn function with argument because the previous presentation we discuss about function with arguments and function prototypes. The next one is function with argument value type. In previous presentation we learned function with argument value type, that is call by value, the function call by value, and also we learned function prototype. The next one is we want to study about the function with argument call by reference. So before that we want to know about the pointers. So the reference is the address of a variable. So before that we want to study about the address, pointers and all thing. So pointers. So what is a pointer? Pointer is point the another variable location. That is the straight meaning of pointers. So integer A is we declare one variable. A is an integer variable. It has 2 bytes in memory. Then we assign A equal to, for example, if A equal to 54. If A integer A equal to 54. That 54 is assigned to that location. If A equal to 54, that 54 is assigned to in A location, but it is 2 bytes, totally 16 bit. The 54 is converted into byte. That byte are stored in memory. It is already discussed in operator section. So data types and operator section. So 54. So at the time of this is a declaration. So at the time of compilation, at the time of program execution, that is at the time of execution, so compiler requires to 2 bytes from operating system, because operating system is a whole control of memory. Operating system is a whole controller of memory. So operating is do the memory management. So at the time of compilation and execution, the time of execution, compiler asks memory from operating system. So that operating system allocate memory. At the time of booting, that is operating system in Windows, Linux, Unix, Xenix. At the time of computer booting, if access memory, RAM memory. So computer consists of 2 memory. One is primary memory, secondary memory. The primary memory is also called as internal memory. Secondary memory is a hard disk, external hard disk, pen drive, and these are all the secondary memory. Secondary memory is also called as auxiliary memory. In primary memory, that is RAM memory. For example, in our computer i3 processor, 4 GB main memory, 500 GB hard disk. So 500 GB is a external memory, that is auxiliary storage device, and that 4 GB is a internal memory, that is a RAM memory. So at the time of booting, computer detect all parts of computer and fetch through device driver, then it access memory, RAM memory for 4 GB. So 4 GB has approximately 4000 MB. In 4000 MB, each 1 MB consists of 1000 KB. 1 KB consists of 1000 bytes. So each byte has 8 bit. But each and every byte at the time of booting, operating system is assigned address for each and every type of each and every bytes. So each and every bytes has one address. That address should be in integer form. That address given by operating system at the time of booting. So that address is 200 because integer A. So at the time of execution, it asks 2 bytes from operating system. So it allocate 2 bytes for the name of A. So that 2 we assign, that is A equal to 54. That 54 is assigned to 2 bytes in binary form. So each and every byte has some address. So that address assigned by operating system at the time of booting. This is kind of memory management. So this is done by operating system. So the 200 is a address. So the 200 is a address for this location. This location, that is A is a location name. In that location name, we assigned value 554. So this location has 2 bytes. The first byte address is 200. The first byte address is 200. The next byte is 201. So 200 201 is a address of it is that address 200 201 is a address. That address assigned for a variable at the time of execution. So but in internal reference, it will take only 200 because the if integer, the adjacent one byte is a integer location. If float, the adjacent 3, the next 3 address is a that variable locations. So for internal operation, it take the first byte address 200 only. So 200 201. If at the time of accessing, so for internal operation we take 200 only. Then if at the time of accessing, based on the type, it access 2 bytes, that is 200 201. If it is a float, it access 200 201 202 203. So each and every variable, each and every device, each and every component of computer has address, that address given by operating system at the time of booting. So this is the memory address. So a variable has that is location name, value at location, address. If we declare float B, so B is in the name of B, it allocate 4 bytes at the time of execution that from operating system. So we assign B equal to 67.56. The binary of 67.56 is assigned to 4 bytes. So if operating system assign 400, it is internal operation. But at the time of accessing, it will take the next 3 location address, that is 400 401 402 403. If we declare character C, so name of C, it allocate only 1 bytes. So that address may be 700. That address is given not by user. This is at the time of booting. It is a fixed one. It is a fixed one mean that is each and every byte has unique integer address, that is continuous value in integer form, that given by operating system. It's not by user. But address of all type, just we see the example. So this address, integer variable address is in integer form, float variable address is in integer form, character variable address is in integer form. It may be any type. The size of the variable may be vary. So integer mean the size is 2, float mean 4 bytes, double mean 8 bytes. But that address is in integer format only. So integer a. In this example, integer a, then a equal to 54. This is a program, that is main. Integer a equal to 54. So it allocate 2 bytes, and then 54 is assigned to that memory locations. For example, the compiler asked operating system to allocate 2 bytes of memory for a variable. So that address is 200. It may be 200. For example, it is a 200. Then we give printf percentage d percentage d percentage d, then a and a star of and a. So for a, this is a integer specification. It is a format specification for integer. So a, it is an integer variable. It give 54. A, it is 54, and a give 200. This is address of that variable. Star of and a, that and a give only 200. If we put star before the address, it give value, that is 54. So if we want to get address of a variable, just we put ampersand symbol. So that ampersand some symbol is a address of variable. If we put ampersand symbol before the variable, we can get address. If we put star before the address, we can get value. So ampersand symbol for represent the address of, star symbol represent value add, star put before the address and before the variable. Then pointers, now we learn pointer variable size are 2 bits. So all pointer, now we learn about the pointer variable. So here we introduce the pointer variable. So in the integer a, this is an ordinary variable. We assign a equal to 54. That value is assigned to that location. Already we discussed it. That is it is a location, it is a value. This is a address. Integer b equal to and a. B is an integer variable. It has 2 bytes. Integer b equal to symbol a, that is address of a. What is the address of a? 200 is the address of a. That 200 is assigned to b. So b also has some address because it has 2 bytes. So it is a 500, 501 is a this is a location address is 500, 501. For reference, we take only first address 500. So this is a address of b. In the location stored in the location, the value is 200. So 200 is the address, but if we assign to ordinary variable, it converted as value only. We cannot able to put star. All characteristics of address is removed here because b is a ordinary variable. If we try to assign address, it converted into value. So it is a value. So it is not a address. In this example, integer star c equal to and a. This is pointer variable. At the time of declaration, if we put star before the variable, this is pointer variable. At the time of accessing, that is printf calculation, if we put star before the variable, this meaning is value at address. It get the value of that address. At the time of declaration, star has a different meaning. At the time of accessing, that is calculating at the time of printf, at the time of accessing. So if we want to print the value, get the address of value, we calculate the pointer variable. We use in expression or printf, it has different meaning. So at the time of declaration, this star called as pointer variable. At the time of accessing, called as value at address. If we put star between two variable, it acts as a arithmetic operator, that is multiplication. If you put a star b, it is a arithmetic operator. If we put star before a single variable at the time of accessing, so it called as value at. At the time of declaration, the star called as pointer variable. So C is a pointer variable. It allocates 2 bytes. So it also 2 bytes mean it has address. For example, it is a 701. For reference, we take the first byte address. It is a 700. So here we assign 200. But the 200 stored as address, it not value, because C is a pointer variable. A pointer variable can hold the address of another variable. If you assign a value to the pointer variable, it treat as address. If you assign address to a ordinary variable, it treat as value only. So if we want to assign a address, we declare pointer variable. So we can assign address only to a pointer variable. So C is a pointer variable. We assign a address of A, the 200 assign as a address. So all characteristics of address is maintained here. But in this case, it converted as a value. All characters of value applicable to this. Here it is stored as a address. All kind of address, the characteristics of address is applicable to here. So this example, float P equal to 19.5. So float P is a ordinary variable. So here we assign 19.5. So it allocated 4 bytes of memory. So P, the address is 600, 601, 602, 603. For reference, we take only first byte of that location. So 600. So 19.5. This is a value. This is address. This is a variable name. Next line, integer star Q equal to and P. So Q has 2 bytes. Q has 2 bytes. So this is also has some address 650, 651. So the address of P is assigned to Q. The address of P is assigned to Q. So 600 is assigned to Q. But Q is a pointer variable. So we can assign address of another variable. But P is a float variable. P is a float variable. But address of all type are integer. This is not a problem. But this is also integer. The address are in integer format only. So that 600, it is a address. The address is assigned to a pointer variable. So it is also possible. But that 600, Q is a integer pointer variable. Q is a integer pointer variable. It may be integer pointer variable or float pointer variable. All variable size is 2 bytes because all variable type of address is in integer format only. All variable type address is in integer format only. So, but 600 Q is a integer pointer variable. At the time of accessing, that 600 treat as integer variable address. That 600 treat as integer variable address. But in our case, P is a float variable address. But Q is a integer pointer variable. So if we assign integer pointer variable, the size is 2 bytes. All type of pointer variable size is 2 bytes. If assign 600, it assigned as address. But that address is a integer type address. So at the time of accessing, it accesses 2 bytes only, 600, 601. But in our case, P is here, that is 600 is a float variable address. So we want to access 4 bytes. Q is an integer pointer variable. So that 600 stored as address of integer variable. So we must assign a float variable address into float pointer variable. But the R size is also 2 bytes. Because each and every type of pointer variable size will be 2 bytes only. So R is also 2 bytes. But this is a float pointer variable. The size is 2 bytes. If we assign float variable address, it assigned as float variable address. So it stored as address of float variable. At the time of accessing, it accesses 4 bytes. 600, 601, 602, 603. So all pointer variable sizes are pointer variable size are 2 bytes. It may be an integer pointer variable or float pointer variable. The size are 2 bytes. But if we assign If we want to assign address of variable, we must follow the rule. That is, integer variable address is assigned to integer pointer variable. Float variable address is assigned to float pointer variable. So then only it access the complete location. If we try to assign a float variable address in integer pointer variable, so the address is integer format, so it is stored, but at the time of accessing, it get only 2 bytes locations. It will not get 4 bytes location. So the value will be wrong. So that's why we must assign address of integer variable into integer pointer variable. This example, it has two program. We first see this program. That is main. Integer a equal to 54 star b equal to and a. So a is a integer variable, b is a integer pointer variable. Here we assign address of a into b. So this is possible. So in printf, totally 3% is there. So a and a b comma star b. So we need 4% d. This is also typing mistake. So a and a b star b. So totally 4 variable is there. So we put 4% d. So a, already we know that. So a is a ordinary variable. If you put percentage d, 54 is display. And a, it display the address. As per our previous example, a address is 200. We assume that address is 200. So it is display 200. B is also display 50. B is also display 200. And A is also 200. B is also 200. Star B, value 200. That is value at 200. Value at 200 is 54. So 54, 200, again 200, 54. It is a typing error. Here we give 4 variable. So we need to put 4% d. So it display 4 value. The first one is 54. The next one is address of A. As per our example, the address is 200. Then here we put B. B hold the address of A. So address is 200. Then star B. Value at address. That is value at B is 200. Just B 200. So value 200, 54. This program main integer a equal to 54 star b, float c equal to 19.5 star d, b equal to and a, d equal to and c. So a is 54, b is a integer pointer variable, float variable c is a float variable, d is a float pointer variable. So integer variable address, a is a integer variable, the address of integer variable is assigned to b. B is a integer pointer variable. Here d is a float pointer variable. Here we assign a float variable address. So it is a valid one. So print of percentage d and a and b. In previous presentation, so we assumed that is 200 for a 700. So based on that, so 200 700. This is example. It may be any address as per our example. So a address is 200, b address is 700. So the next one is percentage d, size of b, size of d. So b is a integer pointer variable, d is a float pointer variable. So here we get size only. So we put percentage d. So size of b, it is an integer pointer variable. The size is 2 bytes. It's a float variable, float pointer variable. The size is 2 bytes. So all pointer variable size is 2 bytes. It may be any type. So integer pointer variable size is 2 bytes, float or double. It may be any data types. The size will be 2 bytes only, because all address are in integer format. So print of percentage d, percentage f, star b, star d. At the time of accessing, we put percentage f. If we give percentage d, it will give wrong value, because it try to access 2 bytes only. But d has float variable address. In this state here we assign float variable c, address of float variable is assigned to d. So we put percentage f. That time of accessing only we put percentage f. So B has only integer variable address. So we put percentage div. So B, just B 200. Value 200, it display 54. D, address is 7. Just D 700 star. Value at 700, 19.5.